Good morning to everyone. This is Pawar Kumar Naidu. Today we are discussing about the nuclear physics. Here we are discussing about the nuclear physics. Nuclear physics is the field of physics that studies atomic nuclei and their constituents and the interactions. In addition to study of other atoms of nuclear matter, nuclear physics should not be confused with atomic physics, which studies the atom as a whole, but including in its electrons. Properties of nucleus. Nucleus is very small and heavyweight, positively charged portion of atom and located at the center of the atom. It has a all the charge of atom are present in the nucleus. Nucleus contain neutrons, protons, and electrons. Hence, these particles collectively are so referred to as nucleus. The size of the nucleus is measured in 1 Fermi is equal to 10 to the power of minus 13 centimeter. The radius of the nucleus of the order of 1.5 into 10 to the power of minus 13 centimeters to 6.5 into 10 to the power of minus 13 centimeter. Generally, the radius of nucleus is 1.4 into 10 to the power of minus 13 centimeters. This exhibit that nucleus is 10 to the power of minus times small in size as compared to the total size of atom. The volume of the nucleus is about 10 to the power of minus 39 centimeter cube and that of the atom 10 to the power of minus 24 centimeter cube. Volume of the nucleus is 10 to the power of minus 59 than that of atom. The density of nucleus of the order of 10 to the power of 15 grams centimeter cube or 10 power 8 tons centimeter cube or 12 kg per cc if the nucleus is spherical. Then density is equal to mass of the nucleus by volume of the nucleus is equal to mass number. What is an atom? Atom is the smallest particle. There are fundamental particles of an atom. As the mentioned above, there are three types of fundamental subatomic particles. They are protons, electrons, neutrons. First, here we are discussing about the protons. Protons are positively charged particles. Proton was discovered by Ernest Rutherford in the year 1919 when he performed his gold foil experiment. He projected alpha particles, helium nuclei at gold foil, and these positive alpha particles were deflected. Pro In Rutherford alpha particle experiment, he concluded that protons exist in a nucleus and hence have a positive nuclear charge. The atomic number or proton number is the number of atoms present in an atom. The atomic number determines an element. The element of atomic number 6 is carbon. Electrons. Electrons were discovered by Sir John Joseph Thomson in 1897. After many experiments involving cathode rays, J. J. Thomson demonstrated the ratio of mass to electric charge of cathode rays. He confirmed that cathode rays are fundamental particles that are negatively charged. Those cathode rays become as electrons. Robert Millikan through oil drop experiment found the value of electron charge. Electrons are located in an electron cloud, which is the area surrounding the nucleus of the atom. There is usually higher probability of finding an electron close to the nucleus of an atom. Electrons can be abbreviated. Electrons have a negative charge that is equal in magnitude to the opposite charge of proton. However, their mass is considerably less than that of proton or neutron. Unequal amounts of protons and electrons create ions. Positive ions or negative ions. Here we are discussing about the neutrons. Neutrons have neutral charge. Neutrons were discovered by James Chadwick in the year of 1932 when he demonstrated that penetrating radiation incorporated beams of neutral particles. Neutrons are located in the nucleus with the protons. After along the proton, they make almost all of the mass of the number of neutrons is called neutron number and can be found by subtracting the number of proton number from the atomic mass number. The neutrons in an element determine the isotope of an atom and often its stability. The number of neutrons is not necessarily equal to the number of protons. Isotopes. We are discussing here isotope. Isotopes can be defined as the variant of chemical elements that possess the same number of protons and electrons but different number of neutrons. In other words, isotopes are variant of elements that differ in the nuclear numbers due to the difference in the total number of neutrons in their respective nuclei. For example, carbon has atomic number 14 and it can be write three isotopes of carbon. 12C, 14C, 13C, 12C are all isotopes of carbon. Carbon contains total number of 8 neutrons. Carbon 13 contains 7 neutrons. Carbon 12 contains total 6 neutrons. Here another example for isotopes are there are three types of hydrogen are listed below. Protium, hydrogen 1. The isotopes of hydrogen contain one proton, one electron, no neutron. Deuterium or hydrogen 2, the isotope contain 1 proton, 1 electron, 1 neutron. Tritium or hydrogen 3, this isotope of hydrogen contain 1 proton, 1 electron, 2 neutron. It can also be noted that these isotopes of hydrogen is radioactive. Applications of isotopes, and an important application of isotope is using determination of isotopic signature of element samples via isotope analysis. This is generally done by process of isotope ratio mass spectrometry. The mechanism of chemical reaction can be determined with the help of isotopic substitution. The change in the reaction rate measured based on the kinetic isotope effect. Isotopes can also use it to determine the concentration of many elements substances via isotope dilution. Applications of isotopes. Some isotopes are used in solving chemical and medical mysteries. Isotopes are commonly used in laboratory to investigate the steps of chemical reaction. The isotopes of uranium is used as a fuel in nuclear reactors. Isotopes are used to give treatment of Guthrie. Isobars. Isobars we can be discussed in nuclear physics, which has total number of protons and total number of neutrons are to be same, and the mass number also should be same. Examples of isobars: argon, potassium and calcium having atoms of same mass number 40. Argon atomic number is 18, potassium atomic number is 19, calcium atomic number is 20. These three elements have same atomic number, same mass number 40. Now here we are discussing about the isotones. Isotones are the atomic species that share the same number of neutrons and differ in the number of protons. Examples of isotopes including carbon 12, nitrogen 13, oxygen 14. These atoms have 6 neutrons and 6, 7 and 8 protons respectively. Applications of isotones. Isotones are elements having the same number of neutrons but different number of protons. Isotope decay emitting radiation that include alpha, beta and gamma rays. Isobar of cobalt is used in treatment of cancer. Now we are discussing about the atomic number. What is atomic number? The total number of protons in nucleus of an atom gives us the atomic number of that atom. It is represented by letter Z. All the atoms of a particular element have same number of protons and hence the same atomic number. Atoms of different elements have different atomic number. For example, all carbon atoms having atomic number of 6, whereas all the atoms of oxygen having 8 protons in their nucleus. Here we are discussing about the mass number. The total number of protons and neutrons combined to give us the mass number of an atom. It is represented by letter A. As both protons and neutrons are present in the nucleus of an atom, they are together called nucleons. For example, an atom of carbon has 6 protons and 6 neutrons. Thus, its mass number is 12, while the number of protons remains the same in all atoms of an element. The number of neutrons can vary. Thus, the atoms of the same element can have different mass numbers and they are called isotope. The weight of an electron is almost negligible. Thus, the atomic mass of an atom is almost same as its atomic. Nuclear physics. Mass defect is also a one subtopic in nuclear physics. The actual mass of atomic nucleus is always less than the mass of protons and neutrons present in the nucleus. When a nucleus is formed, energy is released. The energy is removed in the form of reduction in total mass. The missing mass is known as mass defect and it accounts for the energy released. The mass defect can be calculated by subtracting the original atomic mass from the sum of protons and neutrons present in the nucleus. We are discussing about the nuclear physics. Binding energy is also a part of in nuclear physics. Binding energy, the amount of energy required to separate a particle from system of particles or to disperse all the particles of the system. Binding energy is especially applicable to subatomic particles in the atomic nuclei, to electrons bound to nuclei in atoms, and to atoms and ions bound together in crystals. We can calculate binding energy is equal to mc square. M is the mass of an electron, c is the speed of light. The difference in the mass is called mass defect given by where Z. Mb is the total number of mass of protons, A minus Z Mn. If you want to calculate the mass, if you want to calculate the total neutrons, atomic number mass number minus atomic number.